These are some more videos of definite integrals. So just like with derivatives, we wanted to simplify first. With integrals, we want to do the same thing. So if you can multiply these out, that's exactly what you want to look at, because we still need to be in a general power form. So this is 3u squared plus 3u minus 2u minus 2. And then you always want to rewrite your integral. Make sure you have your a and b. This is 3u squared plus u minus 2 du. And the nice thing with these is you can plug them in the calculator to verify that the answer is correct. So this would become u cubed 3, and then we bring down the 3, plus u squared over 2. Remember, the exponent will always match the denominator, and then to u, and again, draw the line to negative 1. Now we just have to plug it in. So this would become u cubed plus 1/2 u squared minus 2u from 2 to negative 1. And remember, we plug the 2 in first. Always think of it like you're going the farthest and then subtracting the previous one. So 2, and then, oops, I already put the parentheses. 2 cubed plus 1/2 2 squared minus 2, like that. All right, and then I always like to put the minus below and then plug it in. And so that way I can just copy what I have above. Now you can change all the signs, but I'm going to leave them alone. But what you do have to do is make sure you put this one in bracket, and then make sure that you also plug in the number correctly. So it should say negative 1, negative 1, negative 1. Now we can just plug them in our calculator. All right, so let's see what our calculator has to say for the answer. Okay, so we always start with the integral to see what the answer is. Make sure you put the entire inside parentheses. It's 4.5. And so for the first one, we get 6. For our subtraction of negative 1, we get 1.5. And then subtracting the 2, we get 4.5. So it looks like this. 6 minus 1.5 is 4.5. And there's our answer. So simplify first. So that would work the same here. This is the integral from 1 to 4 of x squared minus 1, and then we always rewrite them like this. So this would be from 1 to 4. This is x squared over x to the half minus 1 over x to the half dx. So subtracting those, we would get, I'll move it over here, the integral from 1 to 4. And then this is just 2 take away a half. So 2 take away a half minus, and that would be x to the minus 1/2. So 1 to 4, x to the 3/2 minus x to the negative 1/2. And now we have our nice general power forms. We can add our 1. So remember, we just add the 2 to the top. So 2 plus 3 would be 5/2. And then we flip it. 2/5 minus, and then we're going to do the same thing. So 2 plus 1 would be a half. So 2 plus negative 1 is a half. And then we flip it, and we put our 1, our 4 and 1. So we end up with 2/5 4 to the 5/2 minus 2 4 to the 1/2. We don't have to switch them back. And then we're going to subtract away the 1s. So this is 2/5 to the 1 to the 5/2 minus 2, 1 to the 1/2, and then we plug it in our calculator, just like before, to find out what we get. Okay, so our calculator says it's 10.4, and that's what we get by subtracting them. So we get 8.8 for the first, and then negative 1.6 for the second. Totals 10.4. So 8.8 minus a negative 1.6, right, equals 10.4. And remember, what we're finding here is this. So as our function, so from 1 to 4, the area under that curve is 10.4. All right, let's try one with a trig function. So we have sine x. So what's the antiderivative of cosine? I just said it. It's cosine x. But remember, if you have a cosine, it's got to be negative. And we put pi and 0. So we're going to have negative. And what I like to do if there's a number in front is just put a big bracket here, and then now we can go cosine pi minus cosine 0, like that. And then we can just change the sign. So what is cosine of pi? That's right, -1. Cosine of 0 is 1. And so now you get -2, which is +2. And then again, we can check that very quickly in our calculator. So it's 2. And so looking at our graph right here, this is our sine function from 0 to pi. So the area under that curve is 2. All right, so what we can also do now is create a formula. So say we don't know what our endpoint is. Well, you can call it b. So this would become sine x, b, and 0. And so if you have some variable that you want to use, plugging it in, we would get sine b minus sine of 0. And what is sine of 0? That's right, it's 0. So we end up with just sine of b. So the area under the curve from 0 to b would be sine b. So here I have set up for you. So there's our function f of x cosine of x, right? And we have some a at 0. See, a is 0 now. And so look at our integral from 0 to b of cosine of x and sine of b. You notice they're the same. So as I move my b, you now have a formula for the integral from 0 to b of cosine of x. It's just sine of whatever it is. Whatever letter you want to pick, whatever number you want to go to. Pretty cool, huh?